All right. Good morning, everyone. And thank you for coming to my session today. Today we're going to spend this session talking about consumer-driven contracts and how it can give you, as a developer, the confidence you need to deploy code to production. So my name is Henrik. I am working as a consultant for a Nordic consultancy firm called Knowit. I'm currently living in Lyon in France, and I'm delighted that I get to come all the way here to speak to all of you about this really amazing topic. So today I would like to start this session to talk about the problem. So this is an example illustration of a microservice architecture with only a handful of services. And each square represents a microservice, and all lines are possible communication between them, meaning that one service may use APIs served by the other. So this here is the problem. In a microservice architecture, we may have an unknown number of smaller services working together as a connected system. And this type of architecture makes each individual service easy to develop, to build and deploy, but these services may or may not communicate with each other. And there's no good way of knowing or making sure that changes you make in application A will not change the behavior in any of the connected services. And there's actually no good way of knowing which of these services are communicating with each other at all. So application A could, for all we know, serve data to all 5 of the connected services on this illustration, or it could serve to none. So we have no good way of knowing. So the problem can be extrapolated to this. How can I confidently deploy a new version of my service? So I first started thinking about this problem when I started working as a junior developer 3 years ago. Because in 2015, I was hired as a consultant to work on an old monolithic application. And every time I made code changes, I could run a whole suite of tests that gave me some assurance that I had not broken any of the internal functionality in this application. But we were starting to provide an increasing amount of external REST APIs, and I could never be certain that I did not break any of these external applications that was depending on this monolith. So we jumped to late 2016, and my team was given the task of rebuilding this monolithic application into smaller and more manageable services. And while doing this, we realized that all existing tests were impossible to port. And I was now left without any certainty that changes I made to a single application would not have dire consequences to the system. So the question became even more relevant. How can I confidently deploy a new version of my service? So if we take a look at the microservice illustration once more, we can see that we don't need many services before such illustration becomes very messy and unorganized. And microservice systems can be composed of a handful of services, or it can, in extreme cases, be more than 1,000 services like it is at Netflix or Uber. So how can I, as a developer, be confident that I won't break any services if we have 1,000 interconnected applications? So the real question is, how do we avoid dependencies in a system? And the answer to this question is fairly simple. It's API versioning. API versioning is a great tool used to decouple dependent microservices that I hope that you all use for your current projects. By supporting multiple versions of an API, makes further development possible by removing all the limitations you might have from existing users of the API. Unfortunately, we will risk having to develop and maintain a limitless amount of API versions unless we know when to create new versions and when we can remove old ones. So this next illustration shows the relationship between an API provider and its consumers. So when a provider service creates and documents an API, they are really creating a contract stating to any consumers that wants to use their API. And this contract states, this is how you can and should use the services that I am offering. And when the provider wants to apply some changes to their service, it is their responsibility to make sure that any changes to the API do not break any consumers. So the provider needs to make sure that they do not breach their own service contract. So to decouple the provider from the consumer, we need to use API versioning. And when a breaking change occurs at the provider, the developers will need to create a new API version. But how do we know that we have a breaking change? So one bad solution that comes to mind is that you could start an instance of the provider application and then run integration tests from all the consumers to that local instance. But this will only work if the consumer actually have integration tests to your provider, and that is not guaranteed at all. And this is also depending on you knowing how to find, download, and start every consumer that uses your application. And I bet that most of you have no proper way of knowing each and every application that is using services that you provide from one of your applications. So we need to find a better way of discovering breaches in existing API contracts. And a possible solution to this issue is consumer-driven contracts. So consumer-driven contracts is a testing paradigm where providers of an API encourages consumers to write integration tests for them. And in return, the consumer can be certain that the provider will not make any unwanted changes to the parts of the API that the consumer is using. So consumer-driven contracts tests are exactly like integration tests, but they're runnable from the provider side of the equation. And I will show you all of this in a code demo. So this illustration has so far described the relationship between a provider and a consumer as unidirectional from the provider to the consumer. But to have a healthy relationship between these two applications, we need to expand it to also include consumer contracts. And when the consumer writes consumer contracts, they are essentially telling the provider that this is how I am using your API. So the provider will now have access to information about which consumer is using their application, which endpoints or parts of the API that they're using, and how they're using it. And this is essential information needed to be able to reduce the number of API versions and to ensure stable services to the consumer. So we need to know who is using your API, what parts they are using, and how they're using them. And with consumer-driven contracts, all of these questions will be answered. But how do we do consumer-driven contracts in practice? Well, we can do it by using Pact. So Pact is a framework for implementing consumer-driven contracts into your applications. And it is this framework that I've been using for the code demo that I will show you later. Pact makes it very easy for consumers to write consumer contracts, or pacts as they call them for short. And it does so because it has multi-language support for creating pacts. This means that you can create pacts using the same programming language as you already do in your application. So Pact currently supports languages like .NET, Java, Kotlin, Scala, Ruby, Swift, Go, JavaScript. So it's very versatile. Pact is also language independent in the verification process. And this is great because that lets consumers who write applications using .NET write integration tests using that programming language, even though the provider is using Java. And it's easy to share pacts between consumers and providers, since Pact has created a Pact Broker, which is an application that consumers can upload their pacts to, and where providers can download them when they need to verify pacts. So this here is just a simple screenshot from of a single pact from the Pact Broker. And the Pact Broker presents the pact in a more readable format, and I will show you more about this. So we can now take a look at how consumer-driven contracts is done using Pact. So we can use the same model as before, where step one is that the provider documents their API and exposes this documentation to all aspiring consumers. Step two, when the consumer integrates that API to their service, they write tests to verify that they are in compliance with the API specification. Step three, the consumer can now generate pacts from these tests, and these pacts are the service contract from the consumer to the provider. And these pacts contains information about the endpoints that they're using, what data from the endpoint they're interested in. So in short, the consumer is now telling the provider, this is how I'm using your API. And the last step is the pact verification step. And the provider can now use these pacts during development and perform a pact verification task to make sure that the application is still serving the correct endpoints and the same data from these endpoints as it did before. So the provider is now able to verify that the consumer will not break after a code change in the provider is deployed to production. So I also need to take a minute to talk about contract test versus integration tests, because they are very similar. Contract tests are very similar to integration tests, but contract test does not suffer for what I like to call the integration test hell. So the integration test hell is a combination of some inherent problem with integration tests. So first of all, integration tests are hard to run, because they are dependent on having an existing environment to run in, or they depend on the developer to install and run all necessary applications and databases in a local development environment, because you need to perform requests to a running instance of someone else's application. And integration tests might also fail for unknown reasons. There might be a network issue while running the test, and they will fail even though they should have been successful. And these two problems will together create a third, and that is developers are lazy. So developers are lazy, and they will ignore unreliable tests, especially during development. So I've seen a trend that has been happening where we have integration tests that are using dummy clients and stubbed data. So normally an integration test should be an actual call from your application to the API provider, and a real request will be sent, and if the provider responds, we will perform some validation on that response. But this will be converted to something like this when using stubbed data. So instead of actually using a real client, the test is now using a stub. And this does not really make sense, because in this scenario, the integration test will not actually achieve anything, because we are both using a dummy client and we're using a dummy response. An integration test using mocks and stubs will in fact be stale the second that you complete writing it, because the mock response that you are providing in your test is only a snapshot of how the provider used to work one time in the past. But this illustration is actually a good representation of what a contract test looks like on the consumer side, because the consumer will provide the request that they want to send to the provider and their expectations of what that response should look like from the provider. So the consumer application will only work on dummy data and test doubles, and the real testing will happen on the provider side instead. So the consumer will write consumer contracts, expose their expectations to the provider by, for example, uploading it to a Pact Broker, and then the provider can download them and perform live requests to the running instance of their application. So the consumer has already provided the contract that tells what the request should look like and what the response should be, and you can now verify that behavior. And by separating the creation task on the consumer side and the verification task on the provider side, we escape the integration test hell. So we're going to jump into the demo, and in this demo we imagine that we have a system composed of a lot of services, but we are only going to look at the relationship between service A and service B. Okay, so we will start by looking at the endpoint that we're going to work against. So we have a create person endpoint that is on /version1/person. That's a path. And it takes a person object as input. The person object is plain simple. It has an ID, which is an integer, and it has name, social security number, and address that are strings. And then we store this person object in the database, we assign it a new ID, and we return it back to the consumer with the HTTP status of 201 for created. So that's everything we're going to work with for now. So the first thing I'm going to do, I'm going to show you a simple integration test. So I'm going to unignore this one, and I'm going to try to run it. So this test failed. And why did it fail? Well, if we take a look at the error message, it has connection refused because the provider application is not running. So now we have integration test hell. I'm not able to test my application because I'm not running the other. So I need to start this application, not that one. And now I could actually test. So, but this is not the thing that we're going to look at now. I just wanted to show you what integration test hell is. I hate it. So I'm going to ignore this test once more, because I'm a lazy developer, of course. And we are now going to look at a Pact test. So in this test, I'm just going to create some headers that I want to send. So I'm creating the header that says that the content type should be JSON UTF-8 value. I'm creating a person object, which contains a name and a social security number. And then I'm creating the pact. So when I'm creating the pact, I use a consumer pact builder, and I say that I am the consumer called Pact Consumer, which is the name of this application. And I want to have a pact with the provider called Pact Provider, which is the name of the provider application. And then I give my pact a name. So I say that this is the create new person request. Then I say that I want to make this request to the path version1/person. It should be a post. I want to send the headers that I just created, and I want the body to be the person object that I just created. And then I say that when I execute this request, I expect that the provider application will respond with the same headers, with the HTTP status of created, so 201, and with the following body. And here we're doing some nice things. So what I'm saying here is that I want the body that is going to be returned to have a field called name, which should be of type string and have the same value as in the person object I just created. So I'm expecting the name to be the same when it returns. I do the same for social security number. I want that to be the same when it comes back. And then I say, and I want an integer type. So I want the ID that's going to be returned to be of type integer. But I don't care about the value, because I cannot dictate what the value of the ID will be. So I'm just saying that I expect it to be an integer. And then I create the pact. And then we run this test on the consumer side by using a mock server. So we're using a dummy client and stubbed data, and we're creating the pact. So also for this demo, I have added a Gradle task that is called Pact Publish, and I say that when I build this application, I want to upload this pact to the Pact Broker. So I now want to build the consumer application. So build was successful, and you can also see here that we have the task pact publish, which published the pact consumer to pact provider.json file to the Pact Broker with an HTTP status of 201 because I created a new pact. So now we can jump to the Pact Broker and have a look at it. So this is the main screen of the Pact Broker. I can take and reload it, and we can now see that we have one pact, which is from the consumer pact consumer to the pact provider. And this pact has one interaction. It's a create new person request, and we can see that we want to perform a post to version 1/person with this body as the request body. And then we expect the pact provider to respond with HTTP status 201 headers and a matching body. Another cool thing, it's not going to be as cool in this demo because I only have 2 applications running, but using the Pact Broker, you can also get predefined dependency graphs, so you can see every interaction that you have in your microservice system. So if I click on the Pact consumer, I can now see that the Pact consumer uses the Pact provider application. And if you have loads of applications running, you can see all the interactions. Okay, so we have the pact, we have uploaded it to the Pact Broker, and now I want to verify this pact. So we're going to go to the pact verification test. So this is all the code I need to perform a simple pact verification test. So what I'm saying here is that I am the application called Pact Provider, and I want to get all my pacts from the Pact Broker located at localhost port 3000. And then I'm starting a test target here, and to explain that, we are supposed to run live requests. So we are actually starting the application and performing these requests. So I'm using this test target to say that my application will be at port 8888. So I can now try and verify the pacts. So the test passed. You can see that I verified a pact between pact consumer and pact provider, the create new person request. It had the correct status code, it had the same headers, and it had a matching body. So everything is OK. So now I want to add another pact. So I'm going to go back to the pact consumer, and I'm going to load in step 2. So in step 2, we have added another endpoint for the client. So we're saying that I want to perform a get person request, which is a request to the version 1/person/ID, because I want to get a single person. And then I'm going to create this pact. So again, I'm saying I want to have these headers, and I'm using the consumer pact builder to say that I am the pact consumer and I want to have a pact with pact provider. And then we set a state. So I'm saying that as long as a person with ID equals 1 exists in the database, we want to perform this pact. So, and then we give it a name, get person with ID equals 1 request, and we do the same thing as we did before. So we're just creating a pact, doing some verification, and that's it. So I'm rebuilding the application and uploading the pact. So that was successful. The pact was updated. And another thing that I forgot to mention is that we can see the status of the pact. So right now this pact has a status of changed. That means that the pact was earlier verified, but has been changed. So you need to trigger a new verification or perform a new verification on the provider side. So if we go back to the provider and we want to perform a new verification, and we can now see that this failed. And why does it fail? So the create new person request is still okay, but the new pact is not. So what we'll see here is that we did not find a test class annotated with @state, because we are not handling this new state. So states are, the consumer is expecting something to be in the database, but that will not be there. So I will have to add it. So this is a manual process that I will have to do. So I can go back to the pact verification test, and I can add the state, and I can say public void add person. So what I want to do here is that I want to prepare the data necessary to perform this pact verification. So what I want to do, I want to create a new person with a name of test and social security number of 123. And then I need to add it to the database, so I need to add a database hook here, just real quick. Person repository. And I need to add it to the database. So now I have prepared the state. So now we can try and re-verify the pact. But it still fails. But now it fails because it expected to get a status of 200 back, but it got a 404. Because I have not yet implemented this endpoint on the provider side. So this is a small digression. You have something called consumer-driven development, where you can actually ask your consumers to tell you what they need. So right now, my consumer told me that they need to be able to get a person from the database, and they want to get it by using this endpoint on this path. So it's a digression, but I wanted to show it to you because it is kind of cool if you have many development teams working together. So I'm going to go into the controller here, and I'm going to say that I need to create a get endpoint. And I want to have it on /ID after /version1/person. It should return a person object, as it said in the pact. Get person. I need to handle the path variable. And then I just want to return the person from the database. So I'm going to just say person repository get and with the ID. So now I've added the endpoint, and we can try and re-verify the pact. And we're okay. So now I know that my application provides the data and this endpoint that my consumer is expecting. So okay, so this was a small digression. I want to revert all my changes here, and I am going to show you another thing. Yeah, that can be there. Revert all changes. And I'm just going to re-upload, so I only have this one pact. So now we're now just going to work with the create new person pact. So we can now go back and see. Oh, okay, never mind. Forget what I said. Now I want to make some changes. So I have this endpoint create new person. It expects a person object. It sends it back. But I hate abbreviations as a developer. Because, okay, I wrote this program. I know that SSN is social security number. But the next developer might not know that. So I hate it. So I want to change the name of this field. So I'm just going to have to get this update. I'm so sorry about this. So I want to update the name of this field to be social security number. And I need to change it here as well. Social, like this. So now I have updated the name of a field, and I just want to re-verify that the pact is okay. So I will run the pact verification test. And it fails. And why does it fail? Well, because it does not have a matching body anymore. So the error message now says that the field SSN cannot be nil. So I changed the name of a field, but my consumer expects that field SSN to exist. So now I have a problem. So I could now see the bug, but I need to fix it. So I can just say that, okay, I want it to be social security number in my code, but I can say that it should be a JSON property called SSN. So during serialization and deserialization, it will be called SSN, even though in my code it's called social security number. So I can re-verify. And now everything is okay. So I was now able to do a change in the provider application. And I could discover that my change had actually created an error in the system. And I could fix it. And I never had to perform a live integration test. I never had to deploy to a test environment. I could all see it during development. And that is one of the best things about consumer-driven contracts and Pact. So now I want to do another change as well. So I have a string address, and that does not really make sense because an address is so much more than a string. So I want to add a new class called address. And this should contain a string street name and a string zip code. And now I want to change this data type from string to the new address object. So now I can try and re-verify the pact. And this works. So I just made a change to the API, but I did not break any consumers. Why didn't I do that? Well, if we take a look at the pact, so the create new person request, it says that it sends in an object containing the name and the social security number, and it expects the same object back with only the name and the social security number. So the address field is never used. So I only have one consumer. This consumer does not care about the address field. So I was able to create or apply some changes to it without breaking any of my consumers. And this is something that you only know because you have consumer-driven contracts. Okay, so what I want to do now is that I want to create a new API version. So what I've been doing now is I've actually been changing fields in an API. And you should not really do that. I've just done this now to as an example, but you should never do that. So what I want to do now is that I want to create a version 2 of my API. So I want to just revert all my changes in my original API. So we should use the SSN fields. I was not performing any changes to the names. And I will need to add a new repository for the new API, and I will need to add a new controller for the API. Oh, sorry. So what I want to do now is that I want to have this version 2 of my API should actually send the social security number field. It should not be an abbreviation anymore. And then I want to say that my repository should use the new person object. And my controller should be on the path version 2. But it should have the same endpoints. And it should use the version 2 of the repository. And it should use the newly created person object. OK, so I created a new version of the API, and I can perform a pact verification task just to make sure that I did not break anything. Everything is still fine? OK. So now I want to migrate the consumer. So the consumer should now, instead of having the SSN field, have a field called social security number. It should, we need to update these two. So sorry, social security number, it's OK. In the pact, I now need to say that, OK, we're going to use the version 2 endpoint. We're going to do the same. It's all the same after that, but I need to use the new endpoint. So I also need in the client to say that I'm going to use the version 2, not 3, but 2. OK. So now I can update. Oh. I'm actually going to have an error here. So provider pack test 101.java. So yeah, the error is now that I forgot to bump the version in the pact. So my client has the path version 2, but I'm saying that I want to send a pact to version 1. And if Pact discovers that you never perform a request to this path that you have stated here, then it will throw you an error and say that, OK, you're not doing what you think you're doing. OK, we updated our pact. And we can now try and see if we are still in compliance with that pact. OK, we're not. I thought we were going to be, so I'm going to see what's happening here. OK. So I am no longer providing the real data from the database. So I have an endpoint that says that, OK, when we perform a request to the getPerson, version 2 getPerson, we want to get a person object from the person repository version 2. But if we take a look at the state that we have here, when a person with ID equals 1 should exist, we want to return the person object. But we are returning something from, we're adding the person to the version 1 of the repository. So I need to bump this version as well. So I will have to import the person as well. Example pact provider version 2 person. OK. we need to rename it from SSN to Social Security Number as well. Okay, so we are still in compliance. We have now migrated the consumer from version 1 to version 2, so I should now be able to completely delete version 1 of my API. And everything is okay. So I was now able to see, to test that all my code changes would in fact work without having to deploy or perform live integration tests or anything. So okay, that was the code demo. I'm going to jump back to the presentation. I have just a few slides left I want to show you. Okay, so what should you have learned from this demo? First of all, testing microservices is not an easy task. Neither is having a reliable user experience when using a continuous deployment strategy. So make sure that you as a provider document your APIs well and that you have API versioning if you want to make changes to existing services. You also need to make sure that you as a consumer communicate your expectations to your provider. So in short, consumers and providers need to talk to each other. And I mean that on a development team basis. So if team A develops the consumer and team B the provider, you as developers need to talk to each other. And using consumer-driven contracts is a great tool to give you a platform to start communicating with each other. And be conservative in what you do, be liberal in what you accept from others. So Postal's law, we need to make sure that we are conservative with what we send and liberal with what we accept. So a provider should be able to provide you with more data than you're interested in without breaking your application. So just like we saw with the address field in the demo. And actively using this principle while developing microservices, I actively use this principle while developing microservices to make sure that your application is not fragile. And confidence is the lack of risk. So if you know everything there is to know about every line of code in every microservice in your system, you would not be afraid of making changes to that code because you would know how that change would affect the whole system. But you do not know this. So you need to find something to help you remove the risk of applying changes to a service. Consumer-driven contracts gives you information about who is using your API, which endpoints they're using, and how they're using the data you provide. So by using consumer-driven contracts, you remove a lot of the risk of updating your service because you now have the ability to test that you still provide what the consumer expects. Performing contract verification before deployment will give developers the confidence needed to deploy their application and know that they're still providing the services requested by their consumers. So my best advice to you all, the next time you create a new API or a new endpoint, make sure that you require your users to write consumer contracts. Because that way you will truly have the confidence needed to deploy fast to production. The code demo that you just saw, you can find it on my GitHub. It's github.com/steamo with a 0. If you have any questions, you can reach me on Twitter or you can send me an email. But even better, we're so lucky today to have the creators of Pact in the audience. Could you stand up, please? So if you have any questions, don't ask me, ask them. And thank you so much for your attention today.